So this week, starting in Chapter 5 in particular, you're introduced to PHStat. And PHStat, as you hopefully know, is an add-in to Excel that gives you an alternative to using standard Excel formulas. That's meant to appeal both to novice Excel users who aren't as familiar or maybe not as comfortable using Excel formulas or creating formulas, but it can also be a great tool for experienced Excel users because it will calculate some of the problems for you faster and save you time. So keep in mind that creating formulas in Excel is actually really easy. So once you are kind of exposed to some examples or watch some tutorials on how to create them, you'll see that it's actually pretty easy and you'll catch on to it pretty quick. So first and foremost, don't hesitate to play around with formulas and setting them up in Excel first. But using PHStat will definitely save you time. And although it's not mandatory and you can solve problems in Excel without PHStat, I want to show you a couple of examples so you can see how much time you can actually save by utilizing it for at least some of the problems. So the problem that you see on your screen right now is problem from Chapter 5. It's 5.2.15, and this is a binomial distribution, and we've got essentially an airline that is looking at on-time arrivals, and they've got a historical probability or a historical success rate of 83.3%. And we are looking at the next 6 flights, and we want to know, in the case of problem A or part A, exactly 4 flights, how many or what the probability of exactly 4 flights being on time will be. So here we just use Excel with the binomial distribution function. So it's equals, you see from your textbook, you've got the function there in the formula bar. The inputs are 4 for the number of successes, so number S is the number of successes, 6 for the number of trials. Our given probability of success is 0.833. You have to enter it in decimal form, so it's given as 83.3% in the problem, but we need to enter it as a decimal in the Excel formula. And then this is not cumulative, so we put false there. Not cumulative meaning that we're looking for exactly the number of flights to be exactly 4 that will be on time. If we used true for cumulative, it would mean that we are calculating for the number of 4 and below, 4 or less flights that are on time. So we'd be calculating for 0 flights on time, 1 flight on time, 2, 3, and 4. We'd be calculating for all 5 of those scenarios. So in this case, we're going to use false for the cumulative question. Okay, so you can see with the results of Excel, we've got 0.2014 or 20.14%. And moving on to part B, here we are looking at actually a cumulative example in that we're looking at 2 or fewer flights. So we're looking at the number of on-time flights that would be 0 over the next 6 flights, 1 or 2. So I've calculated it both ways. We've got the equation for 0 successes, so the number of successes, first number there in the formula is 0, as you can see. For the next one, it's 1 for 1 success, and then separately for 2 successes. And if we sum those all 3 together, that would give us our result of 2 or fewer flights being on time. So a quicker way to do that is if we just use the true answer for the cumulative question, along with the number 2 being the number of successes. That would give us the same answer just by using one equation or one formula. But I wanted you to see how we can set it up kind of intuitively, and then also just solve it much quicker with the true accumulation or true cumulative function in Excel. Now for part C, we're looking at least 4 flights being on time. So here we have to break it all out because cumulative would only be if we were looking at 4 or fewer. So fewer than 4, including 4. And so we break this out with 4 successes, 5 successes, and 6 successes, which is the maximum number of flights that we're looking at. So greater than 4, or at least 4, I should say, flights on time, we would include the 4 successes, 5, and 6. So formula is really easy to enter. Again, we use 4 as the number of successes. In this case, we use 5 in the second formula and then 6 in the third formula. Again, false for the cumulative question, all three, and then we sum them together with the sum function equals sum, and we've got 93.73% in this case. And finally, in part D, we're asked for what the mean and standard deviation of this distribution is. So we can calculate this again by hand or with some help with Excel just by solving the formulas. So by definition, the mean is just the number of trials times the probability of success. So you can see my formula up here. I've got equals D15, which is the number of trials, times, which is the star symbol on your number 8 key on your keyboard, and then D16, which is probability of success. So that's equals our mean for the problem. And then for standard deviation, we're using the square root function because the formula is the square root of the trials times the probability of success times the probability of failure. So probability of failure is just the complement of the probability of success. So probability of failure is just technically 1 minus 0.833. So put that all together in the Excel function up here, the formula bar, and we've got a standard deviation of 0.9136. So not too bad to enter this all via formulas in Excel, but we'd actually do it faster if we use PHStat. So what I'm going to do is switch over to kind of a base sheet that I use to initiate PHStat problems. And then once we've downloaded PHStat, you can see there's a new folder over here on the right. We click on that and we go to our probability and probability distributions menu, hit the drop down, we can select binomial. And then here, again, instead of entering Excel formulas or functions, we're just going to essentially enter a text box that will solve the problem for us. So in this case, our sample is 6 flights. That's how many we're looking at over trying to predict. And we got the probability of an event of interest of 83.3%. So again, we enter it as a decimal, so 0.833. And outcomes, we want to look at all outcomes. So since there's 6 different events or 6 flights that we're interested in, we're going to look at 0 to 6. So look at all of them. So we can use the cumulative function, cumulative probabilities function as well. So it'll help us to calculate all of the various questions that we could be asked. So hit OK. And it's going to bring up on a brand new sheet all the different binomial probabilities in a table here. That's really handy and quick to solve the problem. So in this case, you can see the question that we had, the probability of the next 6 flights. In the next 6 flights, exactly 4 will be on time. So probability of X, so probability of 4, we go down to 4. There's our answer, 0.2014. The next question, 2 or fewer will be on time. So if we look out over the headings here, we want less than or equal to X, so that would be less than or equal to 2. And we go down to the 2, and we've got 0.0088, same as our answer that we calculated a little bit long ways in Excel. And then we've got the probability of the next 6 flights that at least 4 will be on time, so we're looking at greater than or equal to 4. That would be this probability here, greater than or equal to X. So in this case, our X is 4. And we get 0.9374, same as we got over here. And then finally, it's asking for what are the mean and standard deviations for this distribution, and those are given to us right here, already calculated out via PHStat. So again, this was a much faster way to calculate all of these answers than it was via the different functions that we created in the previous sheet. And we can do the same thing if we look at a Poisson distribution. So this is problem 5.3.23. And same thing, we can calculate this all out via Excel with our functions very easily. And you can see that we've got our Poisson function here. And you can see that we've got the, for X, we've got our 5 occurrences. We've got our probability distribution with the Poisson figure or mean of 5.4. So the mean's 5.4. And it's not cumulative in part A because we're looking for exactly 5 occurrences. So Pretty simple to put this in an Excel formula and solve the problem. Same thing if we want to do the probability of more than 6 occurrences. So more than 6 occurrences with Poisson, remember that there's an infinite number, potentially an infinite number of occurrences. So in this case, we need to calculate the complement of 0 through 6 occurrences. So this one's a little bit longer doing it via regular Excel formulas because we've got to calculate the probability of 0 occurrences. Let's see, the only number that changes is the first number, 0 in the formula bar. For 1 occurrence, 2 occurrences, 3, 4, 5, and 6. So if we sum these all together, we've got the total of 0 through 6 occurrences, but we are looking for more than 6 occurrences. So what we need to do is find the complement. The complement is just simply 1 minus the sum of the 0 through 6. So you can see in my formula here, it's just equals 1 minus B12, which is the sum of the 6 occurrences. And then in part C, we're looking at the probability of 3 or fewer occurrences. So here we can use the cumulative function. So you'll see we've got 3 as our number of occurrences. We've got the mean of 5.4. And then for cumulative, we say true because we're looking for 3 or fewer occurrences. So again, other than part B, not too bad to solve this via some regular Excel functions or formulas. But if we use the PHStat, when I enter in the data for PHStat, it gives us a great table here that will solve all these questions for us. So the probability of exactly 5 occurrences. So probability of x, x is 5, so probability of 5 occurrences is right here in the table, 0.1728. The probability of more than 6 occurrences is 0.2983. More than 6 would be in this column here. So P is greater than x or greater than 6. So down to the row of 6, and there's 0.2983. And then probability of 3 or fewer, so less than or equal to 3. So probability of less than or equal to x or less than or equal to 3 is here, 0.2133. And again, this would have been a much faster, even faster way to solve this problem than the previous functions or formulas that we used. And if it helps you, I'll back up here a second and show you how I created this table with the Poisson distribution. Go back to my PHStat main page here, where I initiate the tables. Click on the PHStat folder, click on the probability of and probability distributions drop-down menu, go to Poisson, and then we've got the mean or expected number of events of interest, which is given to us as 5.4. Don't really need to put a title in there, just hit the cumulative probabilities, and it creates a table for us. So this is even easier than the binomial distribution table creation. So if you haven't played around with PHStat yet, or haven't gotten to that area of the textbook where it kind of walks you through some of the examples, hopefully this helped you to get a quick look at it and feel comfortable giving it a shot yourself. And certainly, as always, let me know what questions you have.